Okay, welcome to your first lesson on how to solve linear equations. So, what we're going to do here is we are going to solve a series of problems until you become acquainted with it, okay? So, for example, bugs over here. Nice. The first thing that we need to learn is about the additive inverse, okay? The additive inverse of any number is its opposite. For example, the additive inverse of -10 would be +10. Now, how do I know that? Well, when you add them both together, you get 0. 0 is the identity element of addition. Okay, got it? All right, so if I have +5, then the additive inverse is -5. And when you add them together, you get 0. That's how it comes when you do the opposite, you cross them out. All right then. Now the additive inverse of -1/2 would be +1/2. See that? And this is the proof. This is how you know that you got the additive inverse. All right then. Now the other thing I wanted to talk about was the multiplicative inverse. Okay. Multiplicative inverse. Multiplicative inverse. Okay, the multiplicative inverse of any number is nothing more than its reciprocal. The reciprocal of 3/2 is 2/3. Now we're talking about multiplication. When you multiply this number, you get 6/6, which is 1 whole. Okay, 1 is the identity element of multiplication. Very good. All right. If I want the multiplicative inverse of 1/2, then I use the reciprocal. So that will be 2/1. Notice something. The difference between this and the additive inverse here is that you do not change the sign. For example, what is the multiplicative inverse of -3/2? Well, that will be -2/3. As simple as that. Good? All right then. So moving on, the next thing that we need to know is how to find the lowest common denominator. Okay? The lowest common denominator. For example, if you have 2/3 plus, 1/2 plus, 1/5. Okay? And you're supposed to add this. Well, the first thing that we do is we find the lowest common denominator, or also called the minimum common multiple. Let's call it LCD, lowest common denominator. So what we do, okay, this is my method. It's called the method down to 1. So you take all the denominators, the bottom part of the fraction, right? And you start, you know what? Let's add 1/4 over here just in case. All right, so what you're going to do is the following. You take all the denominators, 3, 2, 5, and 4, okay? And now you are going to divide by the lowest number possible except 1. You're going to start dividing at 2. So first, look at these numbers and say, okay, can I divide by any of these numbers by 2? And in effect, you can. This one and this one. So I'm going to divide by 2. 5 does not divide evenly with 2, so it stays at 5. 2 divided by 2 is 1. You see that? Nice. 3 doesn't divide by 2, so it stays at 3. 4 divided by 2 is 2. Okay. Now, I repeat the process until all the numbers are down to 1. So what is the lowest number possible that I can divide by? Well, here I can see that I have an even number. Therefore, I can also, again, divide by 2. Remember, 5 doesn't go into 2, so it stays at 5. This is already down to 1. 3 does not divide into 2, so it stays at 3. Okay? 2 divided by 2 is 1. That's it. Okay. Now, again, what is the lowest number possible? Well, I cannot divide by 2 anymore. So, but I can divide by 3. Okay, can I divide by 3? Yes. 5 doesn't go into 3 evenly, so it stays at 5. 3 divided by 3 is 1. Right? Then, again, and this is down to 1. And guess what? Now your lowest common denominator will be the multiplication of these numbers right here. 2 times 2 is 4, times 3 is 12, times 5 is 60. Okay? And that is your lowest common denominator. Okay? Now, the next thing that I'm going to show you is a different way of finding the lowest common denominator with the same numbers. Okay? This is called finding a common number among the multiples. So you take your denominators, 3, 2, 5, and 4. If you prefer this method, by all means, you're more than welcome to use it. Me, on the other hand, I'd rather the method called down to 1 because it's hard. I mean hard, easier. Sorry, my bad. I gave it away. So here, to find the common denominator, you're gonna actually use the times tables, the multiplication tables. So for example, 3. 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 15, 18, 21, 24, and so on and so forth. 2 times 2 is 4, times 3 is 6, times 4 is 8, times 5 is 10, 12, 14, 16, and so on and so forth. 5, 10, 15, 20, 25, 30, 35, 40, and so on and so forth. 4, 8, 12, 16, 20, times 6 is 24, 28, 32, and so on and so forth. Well, you will continue. Okay, I run out of space, and that's why I don't like this method. You're gonna continue, and there will be a point in time where all the numbers are going to have 60 as the common multiple. And now it only makes sense, because is there a number that multiplied by 3 gives you 60? Yes. Is there a number that multiplied by 2 gives you 60? Yes. Is there a number that multiplied by 5 is 60? Yes. Is there a number that multiplied by 4 is 60? Yes. So you're gonna go on forever until you get 60. Guess what? It takes a lot of space, and you don't want that. All right. So that is the second method. You still get the 60, but it's kind of like longer. It works with small numbers. It doesn't work with big numbers. The next thing that we're gonna do is we're gonna start solving equations right away. Okay, I just reviewed with you additive inverse, multiplicative inverse, and finding lowest common denominator. For example, if you have an equation that looks like this, okay, you have to use the 6 steps. The first thing you ask yourself is, do I have distributive property? The answer is no. Second one, do I have fractions? The answer is no. Third, do I have like terms on the same side of the equation? No. Fourth is, do I have variables on both sides? The answer is no. Fifth, do I have additive inverse? Additive inverse, is there a number adding the x? No. So therefore there is none. 2 is not being added to the x. 2 is actually multiplying the x. If you are able to say 2x, that's a multiplication. If you say 2 plus x, then that will be addition, but there is nothing here that's telling you to add. Okay, so then what is my next step? Well, the last step, the 6th step, is to use the multiplicative inverse. I know what you're thinking right now. To solve this equation, just divide both sides by 2. I totally agree with you, but the problem is that this, when faced with a fraction here, you're not gonna say divide by that fraction because it's gonna become a little complex, a little more difficult. So just bear with me. So what you're going to do is you're going to find the multiplicative inverse of the number that is multiplying the variable. In this case, the number is 2. What is the multiplicative inverse of 2? Well, the multiplicative inverse is 1 over 2. And how do I know that? 2 can easily be turned into a fraction. This would be 2 over 1. Guess what? 2 over 1. I do the reciprocal and I get 1 over 2. That's how I know this is the multiplicative inverse. And you do it to both sides. Now watch what happens. 2x times 1 is 2x over 2. 10 times 1 is 10 over 2. A fraction is a division. I think they're chasing somebody over there. I don't care. Oh well. It's not me. So 2. So you get x. 10 divided by 2 is 5. And x, 5 becomes your solution. As simple as that. See that? Alright. Let us do something more complicated. So let me get rid of this. The 6 steps will always be the same. 1, 2, 3, 4, 5, 6. You have to commit it to memory. Okay? Watch. I'm going to do this problem. 3 plus 2g equals 5g minus 9. Okay. So, I ask myself, do I have distributive property? And the answer is no. Do I have fractions? The answer is no. Do I have like terms on the same side of the equation? This equal sign is what divides the two sides. So, look on the right hand side. Do I have like terms? No. Look on the left hand side. Do I have like terms? No. Okay. But Becker, you have 2g and 5g. I understand that, but they're on different sides. That's why there is the next rule. Do I have variables on both sides? And the answer in this case is yes. Yes, I have variables on both sides. What to do when you have variables on both sides? Get rid of the lesser one. All right? So in this case, 2g is the lesser one, so I'm going to use the additive inverse of 2g, which in this case would be negative 2g, and what you do to one side, you do to the other. See that? Okay, so bring down the 3. 2g minus 2g is 0, so that's it, it's over. 5g minus 2g is 3g minus 9. Okay, let us go on to the next rule. Additive inverse. Do I have additive inverse? The answer is yes. How do I know that? Well, 3 is not adding or subtracting. 3 is multiplying the g. 9 is subtracting. You see that? There is a sign between the number and the variable. Oh, okay. So I know so I know which additive inverse to use. I'm going to use the additive inverse of 9. Okay, so we get 12. We bring down the 3g. This already cancel out, so it's no longer there. Cool? All right then. Now, last but not least, I'm going to use the multiplicative inverse. Yo, Becker, but come on, just divide by 3 on both sides. I understand, but just bear with me, okay? So I am going to use the multiplicative inverse of 3, which is the one multiplying the variable. What is the multiplicative inverse of 3? 1 over 3. Why? Because this is 3 over 1. So 1 over 3, and you multiply both sides by the multiplicative inverse. All right then. Now let us skip one step. Let us skip the step where I say 12 times 1 is 12 over 3 and write 12 over 3. We should be able at this point to say 12 times 1 is 12 divided by 3 is 4. See that? Or you could go backwards. You could say it the other way. Instead of multiplying by 1 and dividing by 3, you could start your division by 3 first and then multiply by 1. Makes no difference. 3g times 1 is 3g over 3. They're gonna cancel out, leaving you with g, and therefore your answer is 4. All right, hopefully you copy that. I'm gonna erase it and I'm gonna move on to another problem. You like my board? Nice board. Nice, Becker, you nice? Of course I'm nice. Okay, let's see now. Let us have another one. Okay. 2 over 3x plus 1/2 equals 5 over 6. Okay? Let me zoom in just in case. There you go. You don't have to see my face. All you have to do is see the problem. All right then. So now I'm gonna go with my rules. Do I have distributive property? The answer is no. Do I have fractions? And the answer is yes, I have fractions. So what to do? Find the lowest common denominator and multiply the entire equation by that denominator. Well, I can play the game down to 1, I could use the multiples, or I could just at plain sight see that my common denominator is 6. Anyway, let's play the game down to 1. So gather your denominators. Where should I do it? Okay, I'm gonna do it over here. 3, 2, and 6. What is the lowest number I can divide by? 2. 6 divided by 2 is 3. 2 divided by 2 is 1. 3 divided by 2 is... Oh, it doesn't, so guess what? Stays at 3. The next number I can divide by is 3, because I can no longer divide by 2. Okay, 3 divided by 3 is 1. 3 divided by 3 is 1. And now multiply this, and I get that I find that my lowest common denominator is 6. Okay, cool then. So what to do? Now that you found your common denominator, multiply the entire function by that denominator. So I am going to multiply the whole thing by 6. This is the same thing as 6 over 1. I just don't write it. It doesn't make any sense to me. All right, so you could do 6 times 2 divided by 3, or you could do 6 divided by 3 times 2. It doesn't matter which one you do first, as long as you understand that you're dividing by the bottom and multiplying by the top. Okay then, so 6 divided by 3, I like division first. So 6 divided by 3 is 2, times 2 is 4, and then x, plus 6 divided by 2 is 3, times 1, 3. 6 divided by 6 is 1, times 5, 5. Okay, now let us go on to the next rule. Do I have like terms on the same side of the equation? No. Do I have variables on both sides? No. Additive inverse. Well, once again, I'm going to ask you, is 4 adding or subtracting? It's multiplying, exactly. You see, I try to throw you off. This is not an addition. This is a multiplication. 3 is the one that is adding. Nice. So then I'm going to use the additive inverse of 3. Now, did I copy it right? Oh, well, who cares? 5 minus 3 is 2. Now I am going to use the multiplicative inverse, or reciprocal if you want to call it like that. So I am going to multiply this by 1 over 4. 1 over 4. So now what happens is that, remember, when you are multiplying by a fraction, you are multiplying by the top and dividing by the bottom. Multiply by the top and divide by the bottom. So 4x times 1 is 4x divided by 4. 2 times 1 is 2 divided by 4, or over 4. Cool. What happens here? The 4's cancel out, but when they cancel out, that doesn't mean that they become 0. Otherwise, if you have 0, then you would lose your variable, because 0 times anything is 0. So 4 divided by 4 is 1. So it's 1x, and 2 over 4 can be simplified to 1/2. Okay? If you have any questions about simplification of what do you call that, fractions, then let me know, and I will explain to you. All right then. So ready for our next equation? Sure. All right, let's do this one. 2x over 5 plus 1 over 3 equals 7x minus 2 over 15. Okay, right here. Let us ask our questions. Do I have distributive property? No. Do I have fractions? Yes. And what do I need to do? Find the lowest common denominator. Now you could rewind this video and figure out how to find it, because I'm not gonna waste time finding it anymore. So 5, 3, and 15. 3 goes into 15, inside, nice. 5 goes into 15, awesomely. Therefore, everything goes into 15. 15 is my common denominator. I'm gonna multiply the whole thing by 15. Now, when you're gonna multiply here, remember, you have a choice. If you could divide it evenly, do it. If not, then you gotta do the multiplication. So, 15 divided by 5 is 3. And this time I'm gonna do it a little bit more in detail. 3 times 2x, okay? Plus 15 divided by 3 is, oh my god, oh no, 15 divided by 3 is 5. 5 times 1. 15 divided by 15 is 1 times 7x minus 2 is 7x minus 2. Okay, cool. Oh, by the way, I'm supposed to say yes over here. Okay. Like terms. Well, before we look for like terms, let us just do these multiplications, okay? Let us go through this. So 3 times 2x is 6x plus 5 equal 7x minus 2. Okay, cool then. Do I have like terms on the same side? No. Do I have variables on both sides? Yes. So that's exactly what I'm gonna do. I'm gonna use the additive inverse of the lesser one. In this case, it will be 6x. So I'm gonna subtract 6x from both sides. Okay? So bring down the 5, because this 6x is no longer here. 7x minus 6x is 1x. 1x, invisible 1 over here, minus 2. All right. Do I have additive inverse? Well, is this multiplying this? Do you say negative 2x, or you say x minus 2? Or negative 2 plus x? Very good. So then I do have additive inverse. So it's going to be negative 2. So the additive inverse of negative 2 is positive 2. X equals 7. There you go. Awesome. All right. Let us do the next one then. If you didn't finish copying and you want to copy, then all you have to do is pause the video and you'll be able to do that. Otherwise, I'll be here till midnight. Okay. Let us do another one, which could be nice to do. Okay. Negative 1 over 3y equals 15. Right away, this is gonna be negative 45, and I'm gonna explain to you why. Listen to me. Distributive property? No. Fractions? Yes. So multiply the whole equation, the entire thing, by the common denominator. You only have one denominator over here. So there's no need to think about the game down to 1, the multiple, the this and that, bada bing, bada boom, bada bang. No. Oh. Nice. Okay. So I multiply by 3. All right. So 15 times 3 is 45. That's fine. Okay. This times 3. So 3 times 1 is 3. Divided by 3 is 1. Negative. So it's going to be negative 1y. We have a problem. You do not wish to have your result, your answer, in the form of a negative variable. So we're going to use the what do you call that, change of signs property of multiplication and division, if you want to. It says that if you multiply any number multiplied by 1 is itself, so it remains the same. Now if you multiply by negative 1, all you're doing is changing the value. Look, y times 1 is 1y. Negative times negative is positive. 45 times negative 1 is negative 45. And that's it. Nice, right? So look, I found my answer at the second step. I didn't have to go through all of them. All right, let's go with another equation. Okay, all right, let us do this one. 2x plus 3x minus 7x plus 1x, no, I'm just kidding, equals negative 10. Okay then, so distributive property, no. Fractions, no. Okay, you could write no next to it. I'm not gonna do it anymore. Fractions, no. Like terms on the same side of the equation, yes. So 2x plus 3x is 5x minus 7x equal negative 10. Notice that I didn't want to do all this. I could have done it with no problem. I just want to show you, how to do it. So this is 5x minus 7x. They are still like terms, so that's exactly what I'm gonna do. Now, one way that I learned how to add sometimes is the following. I have positive 5 of this and I have negative 7 of this. So look at this. 1, 2, 3, 4, 5. Positive 5 of this. And I have negative 7 of this. 1, 2, 3, 4, 5, 6, 7. This positive goes out with this negative. This positive goes out with this negative. Same here, same here, same here. Guess what you end up with? You end up with 2 negatives. In other words, negative 2. It's a plane! No, it's Superman! No, it's beker time. Okay, 5 minus 7x is negative 2x. And that equals negative 10. Okay, so that takes care of the like terms. There is no variables on both sides. Additive inverse, I don't see any number adding the x, so it's fine. Multiplicative inverse, yes, of negative 2 is negative 1 over 2. Negative 1 over 2. Okay? Because this is negative 2 over 1. All right then. So now, what happens here? Let us do this in one step. Negative times negative is positive, so I know that this is going to be positive. 2 times 1 is 2. Divided by 2 is 1. 1 what? 1x. That is the purpose of the multiplicative inverse. To cancel out this value right here and make it a 1. Negative times negative is positive. 10 times 1 is 10. Divided by 2 is 5. And there goes your answer. Okay, let's move on. You could pause the video, you could do whatever. I'm trying to go as slow as possible so you can understand how to solve this. Okay then. So let us do the following. 3 over 5 times x plus 2 equaling x minus 4. Distributive property? Yes. So let us take care of the distributive property. Let me see now. Nice. Okay. So 3/5 times x is 3 over 5x. Remember, when you multiply by a fraction, you're multiplying by the top and dividing by the bottom, or dividing by the bottom and multiply by the top. 2 divided by 5 does not go evenly, so I'm just gonna have to go with the multiplication first. 2 times 3 is 6 over 5, or divided by 5. Now, I use distributive property and I said yes. I'm not writing yes or no here. You write yes or no. Fractions. Do I have fractions? Yes. And what to do if I have fractions? Find the common denominator and multiply the entire equation by that. Okay, cool then. So now let's see what happens. 5 divided by 5 is 1 times 3 is 3x. 5 divided by 5 is 1 times 6 is 6. 5, remember, we're using the distributive property over again. When you use these two steps, one can cause the other one to happen. All right, so 5 times x is 5x. 5 times 4 is 20. So that's minus 20. Okay. Like terms on the same side of the equation? No. Variables on both sides? Yes. So get rid of the lesser one. Additive inverse? Yes. Okay, let me zoom out so you can see better. Okay. Yes. So I'm gonna use the additive inverse of this number. So plus 2 on both sides. Okay. Oh my God, I'm running out of space. So now here, use the multiplicative inverse of 2, which is 1 over 2. But Becker, can you just divide by 2? Yes, you can. Yes, you can. I'm just letting you know that this is the step before that. So when you are faced with fractions, you know what to do. All right, 8 times 1, 8, divided by 2, 4. 2x times 1 is 2x. Okay, that's it. I cannot see anymore. Don't worry, I'll show it to you. Nice. Oh, you could see 4, kind of. All right, and basically x equals 4, and there you have it. All right then. Let us move on to another equation. Oh my God, oh my God. Oh, watch me, hey. Oh, watch me, hey. Okay. Let us do one more problem, and then we'll move on to the next set of equations. So I have 3 over 4x plus 5 equaling 2x minus 6. Ooh, a little ant, hold on. Oh, look at that. I'm gonna show you the ant. You see it? You see it somewhere here? No, you don't see it? Okay, fine. You don't have to see it. All right then. So once again, do I have distributive property? No. Do I have fractions? Yes. So what is the common denominator here? Hello, there's only one here. So you're gonna multiply the whole equation by 4. You multiply by 4. So now let's see. 4 divided by 4 is 1 times 3 is 3x. 4 times 5 is 20. 4 times 2x is 8x. 4 times negative 6 is negative 24. Okay. Fractions, well, I did already. Like terms on the same side of the equation. No. Okay. Variables on both sides. Yes. So get rid of the lesser one. If you want to participate, if you want to call out the answer before it happens, be more than welcome to, okay? I don't have a problem with that. Actually, in fact, every time you call out the answer before I do, then I will grant you 1 point, okay? All right, so next one is additive inverse. Last but not least is multiplicative inverse. See that? Okay then. Now, 5x times 1 divided by 5. The reason for the multiplicative inverse is to get rid of it. 44 times 1 is 44. Divided by 5 is 44 over 5. Becker, I get a decimal. Becker, I get a number. No, don't worry about it. If you leave it at 45 over 5, it's more than correct, okay? Unless somebody asks you to change this improper fraction into a mixed number or to divide it on the calculator, please, by all means, you could just divide it on the calculator and it's fine. The answer, however you represent it, is still going to be the correct answer. All right, so we got that. Let's move on to the next set of equations. Okay, so let us do this one. This is from the problems that I wrote today, this morning. All right then. So let us see. Do I have distributive property? Yes, I do. So I am going to distribute. 1/3 times k is 1/3 k. 1/3 times 2, well, let us do the fraction multiplication, okay? So it's 2 times 1, 2 over 3. And of course, on the other side, I didn't do anything, so it stays at 1 over 6. Do I have fractions? Hell yeah, I have fractions. So what am I gonna do? Find the lowest common denominator. 3, 3, and 6. Does 3 go into 6? Yes. Does 3 go into 6? Yes. So do you know what the LCD is? Do you? Right, it's 6. So then, I multiply the whole thing by 6. Now watch what's gonna happen. 6 divided by 3 is 2 times 1. 2k, not the Xbox One game, not the PS3, PS4 game. 2k. I know it's corny. It works. 6 divided by 3 is 2 times 2, 4. 6 times 1 is 6, divided by 6, 1. Or 6 divided by 6 is 1, times 1 is 1, still the same thing. All right then. So I use fractions. Do I have like terms? No. Do I have variables on both sides? No. Do I have additive inverse? Hell yeah. Oh, sorry. Okay. So 2k. 1 minus 4 is -3. And this time I'm actually, since I've been doing the multiplicative inverse, we already know that's what we're gonna use, but I'm gonna be lenient, I'm gonna be flexible. So divide by 2 on both sides. So your answer is k equals -3 over 2. Ooh, you cannot see it. Now you can see it. Ta-da, 3 over 2. Okay. Damn, I need some water. Let us do another equation. By the way, I have no idea what the answers to these equations are, but, well, let's see what we got. Okay, the next equation is going to be 2 over 5 times 3 plus x plus 1/2 equaling 3 over 2. All right. So do I have distributive property? Yes, I do, right here. So I am going to distribute. So 2 times 3 is 6. So this is going to be 6 over 5. Okay, and now 2/5 times x. So 2 times x is 2x. So plus 2 over 5x. Plus, of course, 1/2 equaling 3 over 2. The next thing is, do I have fractions? Yes, I do. So let's find the common denominator. You could play the game down to 1. You could play the multiples. Who cares? Now, 2 doesn't go into 5, so 2 is going to be one of those numbers. I know that the common denominator is 10, because 2 times 5 is 10, and 5 times 2 is 10. So my common denominator is 10. So I'm going to multiply the whole entire equation by that common denominator. Okay, so 10 divided by 5 is 2 times 6, 12, plus 10 divided by 5 is 2 times 2, 4x, plus 10 divided by 2 is 5 times 1 is 5, equaling 10 times 3, or 10 divided by 2 is 5 times 3, 15. Woo! Okay. Now, like terms. Yes, I do have like terms. Look, 12 and 5. So that is 17. And again, plus 4x equaling 15. Variables on both sides? I don't think so. Additive inverse. Do you think that 4 is adding or subtracting the x? Right, it's multiplying, because you're not saying 4 plus x, you're saying positive 4x. Therefore, it's multiplying. 17 is the one that is being added to the x. See? You could say 4x plus 17, definitely. So I'm going to use the additive inverse of 17. (15 minus 17 is -2). Okay. And now, I am going to use the multiplicative inverse. But since this is not a fraction, then let us just divide by 4 on both sides. Good? This is 1. Okay, 4 divided by 4 is 1. So x equals, what is -2 over 4? That's nothing more than -1/2. You see, I'm not asking you to do decimals when you have fractions, but I'm asking you to at least simplify the fraction into the simplest form. Got it? Okay, so let us move on to the next problem. My God, it's getting dark. Hurry up, Becker, hurry up, hurry up, hurry up, hurry up, hurry up. Oh, okay. Notice that the 6 steps are always the same. All right then, let us do this one. 1/2 times y plus 1 equals y minus 1. All right, distributive property, yes. If you have any questions of how I got this, then ask. Now I have fractions. I find common denominator. Make sense? Okay. How did I get 2 as my common denominator? Hello. All right, so 2 times 1 is 2, divided by 2 is 1. Or 2 divided by 2 is 1, times 1 is still 1. 1y. 2 divided by 2 is 1, times 1 is 1. 2 times y is 2y. 2 times 1 is 2. Okay. Like terms. Nope, nope. Variables on both sides? Yes, yes. Get rid of the lesser one. Additive variables on both sides? No. Additive inverse? Yes. Y equals 3. Nice. All right, let us move on with the next problem. Okay, now that you've seen this is the order of the rules. I'm going to delete the rules because I need more space, but I'm still going to state what the rules are, and you are going to also help me with these rules. All right, so this is the equation. Okay, so the first thing I'm going to ask myself is, do I have distributive property? Yes. Okay, so let us move on with the distributive property. So 2 times 3x is 6x. 2 times 2 is 4. Okay, this is one expression that has the distributive property. This is the other expression that has distributive property. So -4 times x is -4x. -4 times 1 is -4. And that equals 2 over 3. Okay. So I did distributive property. Now what is the next question? 1 point. I'm gonna say it first. Fractions. If you said it first, I'll give you 1 point. All right then. So I have fractions. Yes, I have one fraction, but you know what? This is bothersome, so I don't want it. So I'm gonna multiply by the common denominator. What is my common denominator right now? Correct. Ah, so now you're paying attention. Okay, so it's 3. Okay, so I'm gonna multiply the whole thing by 3. So this becomes 18x 12 minus, what is this? 12x minus 12. 3 divided by 3 is 1 times 2 is 2. Okay. So fractions. Do I have like terms? Yes. 18x minus 12x is 18x minus 12x is 6x. Very good. 12 minus 12, 0. And now I'm going to use the multiplicative inverse of 6, which in this case would be 1 over 6, but it's okay. I'm going to go with the flow. I'm going to go with you, okay? So I'm going to divide by 6 on both sides, because that's what the multiplicative inverse would have done. So this is 1x. 2 over 6 is 1/3. Okay, now I'm going to erase it. You want me to pause it? I'll pause it. I don't have a problem with that. If you have any question about where I got each of the numbers, please ask. Okay then. The next one. All right, so let us solve this equation. My God, it's getting dark. Can you still see that? I hope you do. All right, so distributive property, yes. So please do this before I do it. Somebody cares to tell me where I got this plus 2 over 3? Nice. Okay, now after distributive property, do I have fractions? Yes. So common denominator, I beat you to that, so I won. So it's 6. You see, you got 2 and 3. The only numbers that they have in common is 6. All right, so let us do this. 6 like terms on the same side of the equation. Variables on both sides? No. Additive inverse? Okay. Cool then. Let us move on to the next problem. Remember, you need to have the rules next to it. I just don't have enough space. Too handsome. Okay, so let us do this one. Oops. Okay, distributive property, no. Fractions, yes. Multiply by the common denominator, okay, which is 6. 6 divided by 6 is 1 times x plus 7 is x plus 7. 6 divided by 2 is 3 times 2x (6x) times 8. Well, 6 divided by 2 is 3 times 8, 24. Okay. Fractions, like terms, yes. 7 minus 24 is, I have no freaking idea. 17. So minus 17. Okay. Variables on both sides? No. Additive inverse? What is negative 24 plus 17? Well, you have 24 negatives and you have 17 positives. So how much is that? Seven. Negative. Okay. And then you're gonna use the multiplicative inverse, which is 1 over 7, but since you don't like that right now, okay, since we know the difference, I'm just gonna divide by 7 on both sides and you get x equals negative 1. Hopefully you can still see that. I don't want to re-record this. All right, we're good? All right, let us do another one. Okay, so here we have 0.06x plus 0.09 times 15 minus x, okay, equaling to 0.07 times 15. Okay, so what am I gonna do right now? Well, distributive property, yes. And look, there is also a multiplication over here. So what am I gonna do? Easy. I'm not gonna complicate myself. I'm gonna give you one of these and we are going to start multiplying this. Okay, let's do it together. So here I have nothing to multiply, so it stays at 0.06x, okay? Now 0.09 times, okay, that's distributive property. So times 15 is 1.35, okay? Minus, well, this times x is 0.09x, okay? And that equals, oh my God, I should have started from here and I wouldn't block you. Oh my God, I'm so smart. Okay, so 0.07 times 15, that is 1.05. Okay, cool. Now, do I have fractions? I can turn this into fractions. I don't have a problem with that, but why would I want to do that? So no, I don't have fractions. Like terms. I got this and I got this. So on the calculator, we just do 0.06 minus 0.09. Okay, so this 0.06 x minus 0.09x is negative 0.03x. Then bring this one down. Okay, now do I have like terms? I did already. Variables on both sides? No. Additive inverse? Yes. Okay, so bring down the negative 0.03x, and now we're gonna do the following: 1.05 minus 1.35. That is negative 0.3. I am getting bitten all over the place because of you, because I'm making this video, and now bugs get away from me. Okay, now I am going to use the multiplicative inverse. But since this is not a fraction, you could just divide by, damn, get away from me, by negative 0.03, okay, by negative 0.03. This cancels out, and now we just divide this. So 0.3 divided by 0.03, or negative 0.3 divided by negative 0.03, that is 10. X equals 10. Okay, so I think that's more than enough practice for today. You know what? Let us do the last problem, but because I'm getting bitten all over the place right here, and I don't like that. All right, so let me put away the calculator. Coño! Oh my God! Look at this mosquito. Contrale, damn. You know what, guys? I'm not doing anymore. I'm getting beaten up by everything. So, bye. Thank you. You do the last problem. Watch.